This question says, write the important conditions required for linear combination of atomic orbitals to form the molecular orbitals. Now what happens here? Actually, atomic orbitals can combine, can overlap, and their wave functions can be combined to form two types of molecular orbitals, bonding orbitals as well as anti-bonding orbitals. If the atomic orbitals undergo constructive interference, we get bonding orbitals, and if they undergo destructive interference, then we get anti-bonding orbitals. That is simple. But then, what is the important condition, or what are the important conditions which are necessary so that at least we can combine atomic orbitals to get maybe bonding or maybe anti-bonding atomic or molecular orbitals? And these conditions are as follows. Let's write it down. The first condition, the condition is of energy. I would like to remind you, my dears, that these orbitals are present on different atoms. Please don't confuse them with hybridization. In hybridization, the orbitals are present on the same atom. In LCAO method, or Lakao method, or whatever you might call it, not Pakao, just Lagao, whatever. If two orbitals, if two atoms are combining, that means molecular orbital is being formed when orbital on one atom combines with orbital on another atom. There are two different atoms involved, please remember that. And the very first condition is the condition of energy. And what is that? The two combining atomic orbitals must have same or nearly same energy. Oh wow, what does that mean? That means very clearly that if one s orbital of one nitrogen atom is coming, it cannot combine with 3p orbital of another atom or something. No. The combining atoms, atoms are combining fine, but the orbitals which are combining, the atomic orbitals which are combining to form a molecular orbital, they must have same or nearly same energy. You can neglect all other orbitals even though they are present, we don't care. 1s combines with 1s and it's fine. They're happy, something like that. So energy must be the same or nearly same. What is the second condition? The second condition is that of orientation. What is that? The combining atomic orbitals must combine in a proper orientation. That means they must approach each other from correct directions. And unless the orientation is correct, we will not get a molecular orbital. What does that mean? See, by orientation I can say, what is the orientation of s orbital? S orbital has no orientation, it is a sphere, fine. But is there an orientation with p orbitals? Yes. You have px, you have py, you have pz. Oh my God. So, some p orbitals, if they are directed along z-axis, they would be pz. If somebody is directed along x-axis, it is px. Somebody along y-axis, then it is py. Fine. By orientation, I mean to say that px of atom number 1 can combine only with px of atom number 2. Px cannot combine with py or pz. If px combines with another px and they approach along x-axis only, then you get a sigma overlap. If they approach along any other axis, y or z, you get a pi overlap. But in order to get a molecular orbital, it is very necessary that px will interact only with px, not with py or pz. In a similar fashion, py will form an MO only with py, and pz would form an MO only with pz. So orientation of the orbital is very important. Only orbitals having similar orientations will combine to form MO even though they may have same energy. The third point is a minor point. It says that the overlap must be proper. The overlap must be proper. Okay, what does that mean? Means there should be a significant overlap of the atomic orbitals so that they can combine with MOs. If the orbitals are too far away and if they cannot come close and if they cannot overlap effectively, they will not combine and they will not give you any molecular orbital. Actually, if orientation and energy conditions are met, overlap normally becomes proper only and an MO is formed, but it is just a warning and an essential one that overlap has to be proper. That's it. These are the three fundamental conditions in LCAO method of combining atomic orbitals to get molecular orbitals.